Okay, ladies and gentlemen, lesson 32 is on simplifying and evaluating expressions with integer and zero exponents. A few rules to remember. When we have negative exponents, if it's in the numerator, such as something like that, it moves to the denominator. If it's in the denominator, it moves up to the numerator. So we just flip the spot. We only move the thing that has the negative exponent. So if I have a squared b to the negative 2, just my b has a negative, and so just the b moves and this becomes positive. Okay, zero exponents, anything to the 0 power is 1. And then quotient rule, so when I have two things that have the same base, such as the x and the x, I'm going to subtract the powers. Okay, so we look here in the example problems, a to the negative 5th, we are going to see that it's in the numerator, so we bring it to the denominator, and we can't leave the top blank, so we put a 1 there. All right, here we see just my numerator, p has a negative power, so just that moves the q to the 4th, still stays in the bottom. And again, I can't leave the numerator empty, so I put a 1 there. All right, here I have my negative power in the denominator, so I'm going to move it up to the top. And I don't need to put it over anything. I can write it over 1 if I want to. All right, so here we're going to substitute in 4, 6, and 3 for a, b, and c. So a becomes 4 to the 0 power, b becomes 6, and c becomes 3 squared. Well, we know 4 to the 0 power becomes 1 times 6 times 3 squared is 9. 1 times 6 times 9, we end up with 54. Okay, let's do another one like this. We're going to substitute in 4. So we have 4 to the negative 2 power. Now just the second 4 has the negative power. So just that moves to the denominator and becomes a positive. And then we're going to keep simplifying. So we have 4 over 4 squared is 16, and this is going to reduce to 1/4. Always reduce your fractions. All right, here's using those quotient powers. I see that they both have the same denominator. So what I'm thinking is x is 10 minus 4. That's all happening in the numerator, and I'd end up with x equals 6. Okay, the other thing, the way I think about these problems is I look at them and I say, which one has more, the top or the bottom? Well, the top has more x's. How many x's more? 6. So that's where I get my x to the 6th in the top. Okay, here, you can think about it like this. 9 minus negative 2. So it turns into plus positive. We get x to the 11th. The other thing we can do is move this up to the top right away, x to the 9th, and then it becomes positive. This is a product of powers, so we're going to add them. So we get x to the 11th. Two ways to think of the same problem. All right, here we have some lots going on, but nothing we can't handle. So we have an x and an x to the 2. Again, this is how I'm going to look at it. All right, sorry for that little interruption there. Okay, so I have an x in the numerator and x squared in the denominator. This is where I really think it's helpful to look at it and go, which one has more, the top or the bottom? Well, the bottom has x squared, so I'm going to say that there's one more in the bottom than there is the top. All right, my y's, I have a negative 3 here, so I'm going to move that down. I'm going to ignore it here, remove it down, and now it's positive. So now these two, I can just add their exponents and get y to the 5th. And then I look here, I have a z to the 5th and a z to the 1 power. The top has more, oops, by 4. All right, last one here. It says refer to the table in example 4. If you want to take a look at it, it's on page 200. Really doesn't make a difference if we see it in this problem or not. How many times more intense is the sound of a jet liftoff at 10 to the 1st power watts per square meter than the of a vacuum cleaner at 10 to the negative 5th power per square? Okay, express the answer in exponential and standard form. Okay, so what they want us to do is take, oops, not x. They want us to take 10 to the 1st power over 10 to the negative 5th power. X's, gosh darn. 10 to the negative 5th power, and they want us to simplify this. Okay, this is telling us how many more times intense it is. Well, this has a negative power, so that means I'm going to move it up to the top. So I get 10 to the 1 times 10 So now it's a positive 5 because I moved it. So I get 10, darn x, just happens, 10 to the 6th power, and that would be an exponential, and then we want it in standard form. So when it's to the 6th power, I'm going to take that decimal place that normally would be there, and I'm going to move it out 6 spots. So 1, 2, 3, 4, 5, and 6. So now I'm going to add in zeros. 1, 2, 3, 4, 5, and 6. So I have a comma and a comma. So this is my standard form. All right, there you have it, ladies and gentlemen.